अस्सलाम वालेकुम सर।
Okay, good morning, and thank you very much, everyone who has showed up this morning. We're going to start just a little bit of confirmation. If you can see the shared screen.
Yes, sir.
Thank you very much. Okay.
सर मैंने एक क्वेश्चन पूछना था।
अभी तो स्टार्ट ही नहीं हुआ यार।
नहीं सर, कोर्स के बारे में था।
हाँ पूछें।
कि अभी हमारा लॉन्ग वीकेंड है तो इस पे हमें क्विज हमारा होगा और असाइनमेंट मिलेगी हमें लॉन्ग वीकेंड में।
अगर नहीं कहा कि नहीं होगा तो होगा।
ठीक होगा, क्विज भी होगा मंडे को क्योंकि छुट्टी है।
सब कुछ वैसे ही है, सब कुछ वैसे ही है।
ठीक होगा सर, शुक्रिया।
जी जी। ओके। So we are going to do a quick recap of last lecture for continuous random variables, and we will show you a few more examples. Last time Dr. Asim covered a lot of ground on the random variables and the functions of the random variables, some examples of the random variables, expected value of the function of the random variable, and transformations. Well, he started on the transformations of the random variable. We'll have a few examples of each of those, just to make sure that that the material we covered on Friday, you have additional examples of those, and we will cover additional topics today as well. So we, for continuous random variables, just like we had defined the CDF and the PMF for discrete random variables, similarly for the continuous random variables, we define the CDF, cumulative distribution function or probability distribution function. We will use just CDF for the probability that X is less than or equal to some value X. That's exactly the same definition that we had for the discrete case, exactly the same definition. The probability density function, since it's a continuous random variable, I cannot add the values. I will need to integrate the values instead of adding the values. So I will integrate the values. The PDF will be evaluated from whatever point. So in general, the PDF would be written as the probability density function. Okay. And the way that we define the probability density function is that this random variable X, taking a value between A and B, this probability is equal to the probability density function. The definition of the density function is such that it is a function which integrated from A to B for any value of A and B gives you the probability that the random variable takes the value between A and B. This is the definition of the probability density function. कि probability density function को अगर A से B तक integrate कर देंगे तो आपके पास probability आ जाएगी that the random variable takes the value between A and B for any A and B. For any A and B. That's how we define the probability density function. Or again, if you compare it with the discrete case में आपके पास probability mass function था इस type का. Yeah. So your random variable taking these values with certain probabilities, and if I ask you कि क्या probability एक random variable इस region में fall करेगा, you will just add the probabilities जो इस region के अंदर fall करती हैं, इस region में जो fall करती हैं. Similarly, we have the PDF, the probability density function, something like this. Okay, always positive or non-negative, I would say. So we have the probability density function. This was the probability mass function. For discrete case. for discrete case, and this is for the continuous case. And if I ask you what is the probability that the random variable falls within this interval, once again, you will add up all the values between this guy and this guy. But in the continuous case, adding up means you find this area under the curve, So integrate from point A to point B, this density function, to get the probability that your random variable falls between A and B. And this leads us to this property that probability X is equal to A would really be, by considering this expression, this would be from A to A, the density function, which is always 0. What that means is that the probability that your random variable takes a specific value will always be 0 or very, very close to 0. So adding all those values up, the density function, just like the probability mass function, adds up to 1, the density function integrates up to 1. Minus infinity to plus infinity. अगर इसको integrate कर देंगे तो ये आपके पास 1 आ जाएगा. So probability density function, your random variable falls somewhere in this range. So the probability that it will fall from minus infinity to plus infinity, this will always be 1. This simply says what is the probability that your random variable falls between minus infinity and plus infinity. What this expression also tells you, the first one, is that probability X less than equal to A is the same as probability X less than A. क्योंकि equal to वाली probability 0 है. So इसका मतलब है कि यहाँ पर ये भी CDF है. Pure continuous random variable के लिए ये भी CDF है. This is also the cumulative distribution function. Okay. So probability density function, PDF, is always non-negative for obvious reason. क्योंकि अगर negative होगा तो उस थोड़े से portion पे मैं integrate करके negative answer ले लूंगा, which means के probability किसी चीज की negative हो जाएगी. Never the case. Axioms हमें ये बताती हैं कि it should never be the case. So PDF, the probability density function, I know Asim used this capital PDF for actually CDF and small PDF for the probability density function, but just to avoid any confusion, we will use CDF for the cumulative distribution function and PDF for probability density function. And PDF is always non-negative. What that also means is K probability X less than equal to A or probability X less than A, which is CDF, is always non-decreasing क्योंकि probability negative नहीं हो सकती, इसलिए ये non-decreasing होगा. And CDF evaluated at minus infinity. What is the probability that the random variable takes a value less than equal to minus infinity? Answers in the chat window. This should be 0. CDF at this capital Fx of X is equal to 0 or minus infinity should be 0. Similarly, CDF of plus infinity is equal to, answers in the chat window, is 1, or Fx of plus infinity is equal to 1. And the probability that random variable takes a value less than equal to infinity always takes a value less than equal to infinity. Always does that. So 100% probability. Okay. Now, there was a relationship between CDF and PDF as well. You can convert one from the other, just like in the case of PMF, you can get the CDF from PMF. Discrete के case में, if you remember, कि वो जो jumps थे, वो jumps in the CDF, they were telling you the probability mass function values. ये जो आपके पास PMF की values आती हैं, ये जो इतनी value आई है, this is the jump. Again, ये जो value आई है, ये CDF का jump है, ये CDF का jump है. Now, same thing here, कि आपने CDF में इन सबको accumulate किया हुआ है, ठीक है. So similarly, in the case of in the case of continuous random variable, the CDF is an accumulation. This is the probability x takes a value less than equal to x, or it can be written as the probability minus infinity is less than equal to x is less than equal to x. Same thing. Okay, probability x takes a value less than equal to x is the same as कि वो minus infinity और x के बीच में कोई value ले लेते हैं, which is the same as minus infinity to x fx x dx. और ये मैं वेरिएबल ऑफ इंटीग्रेशन जो है वो मैं चेंज कर देता हूँ, t कर देता हूँ dt, क्योंकि ये इस x के साथ फिर कंफ्यूज ना करें. इट्स रियली t ले लें या जो भी ले लें, आखिर में हमने वैल्यू x ही पुट करनी है, तो आंसर आपके पास x की शक्ल में ही आएगा. So you will have a function of x. Similarly, if you can integrate the PDF to get the CDF, similarly you can differentiate the CDF to get the PDF. So fx of x would be equal to the derivative of these relationships are going to be very useful when you are finding the probability density function of a random variable. तो आपको एक random variable x दिया हुआ है, उसका probability density function भी पता है, and now you are being asked that why is some function of x, and try to find the probability density function of x, and we will take a look at that example. So this is some basic recap of the continuous random variable, some properties of the PDF, CDF, simple extension of the concepts that we learned in the case of discrete random variable. Simply उसकी extension है. There is some more detail to it कि इसमें probability density function की height जो है वो 1 से बड़ी हो सकती है. The answer is yes, because we are interested in the integration area. As long as the area under the integral of PDF is equal to 1, height बेशक 1 से बड़ी हो जाती है, कोई फर्क नहीं पड़ता. Okay. There is some more explanation in the notes, a couple of pages of less than a couple of pages actually. So please go through the notes जो हमने पहले ही upload कर दी हैं. I'm now going to talk about the expected value and the variance. Expected value और variance के बारे में बात करते हैं. Okay. Just like in the discrete case, if you recall, discrete case में हमने expected value of x कैसे define की थी? हमने कहा था कि sum up कर दें over all possible x. किस चीज को sum कर दें? उसकी possible values the random variable can take multiplied by the corresponding probability. The PMF multiplied by the corresponding value. इन दोनों को multiply करें and sum over all the values of x. Sum over all the values of x, which is also the probability x takes the value x. So ये discrete के case में था. Okay. By the same token, for the continuous case, and there's some probability justification for this as well in the notes, but I'm just going to write this down. Just like it's the summation of values multiplied by the corresponding probabilities, the expected value for the continuous case is also the value multiplied by the corresponding probability. Lekin in this case, the probability is not fxx, this is probability density. Density को आप length के साथ multiply करने तो ये आपके पास probability. This is the probability that your random variable takes a value in the vicinity, in the small vicinity of x, which is dx. इस interval में fall करते हैं. And since you have to sum it up for the continuous case, I have to integrate it. And integrate it from minus infinity to plus infinity, or all possible values of x. कभी कभी इसको ऐसे भी लिख देते हैं, sum over all x fx x dx. Okay. What this means is that the random variable की पूरी range जितनी है जिसपे वो non-zero है probability density function, उसके ऊपर आप integrate करते हैं, which is the same as integrating from minus infinity to plus infinity. Now, just like we can find the expected value of a random variable, we learned in the discrete case, the function of a random variable is also a random variable, because random variable itself is the mapping of the outcomes onto the real line. और उस real line के ऊपर जो number आए हैं उनकी एक और mapping कर दें, तो हम यूं समझ लेंगे कि ये डायरेक्ट ही आपके आउटकम्स जो हैं वो फाइनल वैल्यूज पे मैप होंगे. सो function of a random variable is also a random variable. If it is a random variable, it is natural to talk about the expected value of that as well. So expected value of some function of a random variable is equal to, well, just like in the case of x, I had this x here. Similarly, in the case of gx, I have gx here, and the density function of x dx integrated from minus infinity to plus infinity. So that is how you will be able to find the expected value of a function of a random variable. What about the variance? This is the expected value. What about the variance? Now, the variance of the random variable x, no different definition. It's the same definition as for the discrete case. And the definition is x minus expected value of x for every possible value of capital X. आप इसको लेके स्क्वायर करें और उसकी expected value लें, you will get the variance of x. And then simplifying, इसको थोड़ा open up करें, simplify करें square को खोल के, then you will be able to get expected value of x square minus expected value of x whole square. Average of the squares minus the square of the averages. Average of the square minus square of the averages. And variance is always greater than or equal to 0. In fact, random variable होगा तो greater than 0 ही होगी. Zero variance का मतलब यह है कि आपके पास कोई variation ही नहीं है values के अंदर. So you have just one fixed number. उसकी variance 0 होती है. Great. Now I'm going to give you an example which is talking about the how to find the PDF of a function of a random variable. कैसे find out करते हैं? You are given a random variable x. Let's say आपको x दिया हुआ है जिसका probability density function fxx is defined for you. The probability density function is 1 when x is between 0 and 1, x is and 0 otherwise. The shape of this guy looks like the following. Okay, this is between 0 and 1. Between 0 and 1, this guy is 1 and it is 0 otherwise. It is 0 otherwise. Otherwise 0. Small x here. You can notice that the area under this curve, this is the PDF because it is always non-negative. हमेशा non-negative है, and the area under this curve is 1. Area under this curve is 1. तो ये दोनों properties जो है PDF की satisfy करता है. This can be the PDF. And in fact, we use this PDF as an example. Okay. Now, define a function of x. We know the PDF of x. Define a function of x. Let's say y is equal to e to the power x. E to the power x. It's a function of x. Okay. And I'm being asked, what is the probability? What is the probability that y takes a certain value? Or what is the expected? Y के बारे में कोई question पूछते हैं. In order to answer any question about y, I need to find the PDF of y. And how do I find the PDF of y? In order to find the PDF of y, just use the definition. Find the CDF and PDF. एक मालूम कर लिया तो दूसरा इंटीग्रेट डिफरेंशिएट करने से आ जाएगा. PDF of y. इसमें हमारा इंटरेस्ट है. क्यों इंटरेस्ट है? Because we are interested in finding this because we want to answer some probability questions about y, or we want to find the expected value of y, or we want to find the variance of y. कुछ भी करना चाहते हैं y के बारे में, कोई सवाल का जवाब देना चाहते हैं, probabilistic question है. So in that case, I must know the CDF, PDF of y. CDF or PDF of y. If you know one, you already know the other. So how do I go about this? In order to find this out, just use the basic definition of the CDF. fy of small y. It's the probability that capital Y is less than equal to y. Everyone is okay with that? Yeah. Okay. So this would be equal to the probability. Just put this value here. Y is equal to e to the power x. Y is equal to e to the power x less than equal to small y. And then this can be written as the probability. और ये अंदर जो आपके पास inequality है, दोनों साइडों के ऊपर इसका natural log ले लें. So this would be equal to x is less than equal to natural log of y. X is less than equal to natural log of y. ये हम y का CDF निकाल दें. By the way, this guy on the right hand side, everyone recalls कि probability x is less than equal to small x, ये क्या चीज होती थी? This is the CDF of x. ठीक है? So if you look at it and compare it with this guy, you will see that this is the CDF of x evaluated at small x is equal to ln y. So this is really f of x evaluated at ln y. So fy of y. So यहाँ पे हमने क्या किया? This is CDF of y on the left hand side. On the right hand side is the CDF of x. We know the CDF of x. We know the CDF of x. In fact, we know the PDF of x. We know the PDF of x here. ये PDF है आपके पास. तो इसमें से CDF easily निकाल सकते हैं. कोई issue नहीं. What is the PDF of x? Fx of x is equal to integral. ये देखें यहाँ पे minus infinity to x capital Fx x dx. That is how you find the CDF from the PDF. देखें when x falls between minus infinity and 0, तो कुछ एरिया ही नहीं है उसके अंदर. तो इसको मुझे माइनस इन्फिनिटी से इंटीग्रेट नहीं करना है, इसको मुझे इंटीग्रेट करना है फ्रॉम 0 to x f of f which is equal to 0 to x 1 dx, which is really x, and for only between x 0 and 1. This is our CDF. और CDF कैसा लगेगा? CDF ऐसा लगेगा. मैं ये ऊपर ही ड्रॉ करता हूँ इसको. So I'll draw it up here. CDF will look like the following. Okay, ये आपका यहाँ से, और CDF is equal to x between 0 and 1. So this will look like this. और उसके बाद constant, और उससे पहले ये 0. ये CDF है. ये 1 पे चला जाता है, और infinity तक ये 1 पे ही रहेगा, और minus infinity तक ये 0 पे रहेगा. In between 0 and 1, the CDF of x is this linear line here, which is given by x. Yeah. This kind of probability density function and CDF, this random variable, is called a uniform random variable. It's called a uniform random variable. Now, since we know that fx of x is equal to x between x whenever x is between 0 and 1, so that means कि ये यहाँ से हम लिख सकते हैं कि f by of y is equal to ln of y. Is ln of y. क्यों? क्योंकि fx of x is equal to x. So fx of ln of y क्या होगा? ln of y होगा. But only when 0 is less than ln of y is less than equal to 1. Only under these conditions. Very important कि ये limits आप दें. Limits नहीं देंगे तो कुछ और आ जाएगा. Now we know the CDF of y. Once we know the CDF of y, it is easy to find the PDF of y. Differentiate to find the PDF of y. Differentiate to find the PDF of y. to find the PDF of y, fy of y will be equal to ln of y को differentiate करें तो you get 1 over y, 1 over y. और ये जो लिमिट्स हैं इनको हम लिख सकते हैं, सबकी e पावर तीनों जगहों पे e पावर ले लें, so this would be 1 is less than equal to y is less than equal to e. इसको ड्रॉ करके देख लें, कि you have y here, you have 0, you have 1 and you have e. So 1 और e के दरमियान में ये आपके पास आ जाएगा, इस तरह की कोई चीज आ जाएगी. And then 0 here and 0 here. ये आपका PDF of y बन जाएगा. This would be the PDF of y. You can find the expected value of y. As minus infinity to plus infinity. और in fact मुझे minus infinity से plus infinity करने की जरूरत नहीं है. Why? Because you know कि it's only non-zero between 1 and e. So all you need to do is integrate from 1 to e 1 over y into y dy. So वैल्यू मल्टीप्लाई बाय द PDF, उसको इंटीग्रेट करते हैं बिल्कुल उसी तरह जैसे एक्सपेक्टेड वैल्यू के ऊपर हमने डिफाइन की थी. एक्सपेक्टेड वैल्यू ऑफ x इज इक्वल टू x मल्टीप्लाइड बाय द डेंसिटी फंक्शन, उसको इंटीग्रेट करते हैं. यहाँ पे एक्सपेक्टेड वैल्यू ऑफ y इज y मल्टीप्लाइड बाय द डेंसिटी फंक्शन. सो दिस इज सिंपली इक्वल टू, ये देखेंगे 1 ही आ गया आपके पास. 1 को इंटीग्रेट करेंगे तो आपके पास y आएगा. सो दिस इज e minus 1. That's the answer. Oh, by the way, ये हम डायरेक्ट भी कर सकते थे. Without finding the PDF, CDF of y, हम ये डायरेक्टली भी मालूम कर सकते थे. Expected value of y, हमें पता है कि y is e to the power x. Expected value of e to the power x, ये expected value of a function of a random variable. So this would have been e to the x into 1 integral 0 to 1 dx. यहां पे मैंने क्या किया, यहां मैंने वो वाला फॉर्मूला लगाया, expected value of a function of a random variable is equal to that function multiplied by the PDF integrated over the support set, which is 0 to 1, and you will simply get e minus 1. एक लाइन में ही आंसर आ गया. ये सारी एक्सरसाइज का कोई वो नहीं है, लेकिन the reason that we did is this exercise. हमने इसलिए नहीं कि ये एक्सरसाइज की एक्सपेक्टेड वैल्यू ऑफ y फाइंड करनी थी. I wanted to answer any probability question about y. If I wanted to answer the question, what is the probability y takes a value less than 2? What is the probability y takes a value less than 2? So the probability that y will take a value less than 2 is this area under the curve. This is the probability that y takes a value less than equal to 2. वो हम इस एक्सपेक्टेड वैल्यू के फॉर्मूले से आंसर नहीं कर सकते थे. उसके लिए हमें पीडीएफ ही चाहिए था y का. उसके लिए y का पीडीएफ ही चाहिए था. Hence the exercise. So we talked about the expected value, we talked about the variance, we talked about the function of a random variable and how to find the PDF CDF of a function of a random variable. There is a lot more detail about finding the function of a random variable towards the end of these notes. Class notes जो ये number 5 हमने number 4 या number 5 I don't know, whatever is the latest जो हमने share की हैं, उसके end के ऊपर you will have a few working examples, 3-4 examples and simple examples, not very complicated, simple examples हैं जिसमें one random variable is given and you have to find the density function or probability density function or CDF of another random variable which is a function of the first random variable. Now, talking about expected value and variance, so it is appropriate to talk about the expected value and variance of a function of a random variable, but not just any function, of a linear function. Y is equal to ax plus b. X is a random variable, y is a function of that random variable. I am interested in finding the expected value of y and the variance of y given the variance or expected value of x. मुझे पता नहीं है x की क्या डिस्ट्रीब्यूशन है, मुझे उसका PDF नहीं पता. So appreciate that if you know the expected value and the variance of a random variable, that does not tell you about the PDF of the random variable. PDF tells you completely about the random variable. CDF tells you everything about the random variable. Probability mass function for the discrete case tells you everything about the random variable. Okay? But the expected value does not tell you everything about the random variable. The variance and expected value together, they do not tell you everything about the random variable. They tell you something about the random variable, but they don't tell you everything about the random variable. Okay? So expected value and variance of a linear function y is equal to ax plus b. Okay? So let's say you are given expected value of x and the variance of x. Expected value of x and variance of x are given or known. I am interested in expected value of y and variance of y. That is my interest. How do I find the expected value of y and the variance of y? Well, ये हमने discrete के केस में किया था. Exactly the same is applicable here. So expected value of y would be equal to the expected value of ax plus b. A and b are constants. Okay? And expectations are linear. Expectations are linear. ये हमने discrete के केस में भी देखा था और continuous के केस में भी. Just look at the definition of expectation. Just look at the definition of expectation. It's an integral of different portions. Integral of different portions. इसमें से constant जो भी होगा वो बाहर निकल आएगा. जो constant होगा बाहर निकल आएगा. And integral of the sum is equal to the sum of integrals. Yeah. So integration is a linear function. So I can write this as a times expected value of x plus expected value of b, which is b. Expected value of a constant is just that constant. So a times expected value of x plus b. This is the same thing as saying कि क्लास के स्कोर्स थे, क्लास के स्कोर्स को आपने एक कांस्टेंट से मल्टीप्लाई कर दिया, डबल कर दिया लेट्स से, तो आपके पास उसमें बाद में आपने उसके अंदर एक कोई कांस्टेंट और ऐड कर दिया. सो व्हाट यू विल गेट, द एवरेज विल गेट मल्टीप्लाइड विद दैट नंबर, डबल नंबर हो जाएगा और वो जो कांस्टेंट आपने ऐड किया था वो उसके अंदर आ जाएगा. सो अज्यूम दैट a इज 1. अगर a 1 है आपके पास तो इसका मतलब है कि x के अंदर मैं हर x की वैल्यू में b ऐड करता जा रहा हूं, तो इसका मतलब है कि एवरेज के अंदर भी b ऐड हो जाएगा. ठीक है. और if b is 0, then if I'm doubling the score of every student in the class, then the expected value or the average value of the class scores would also be doubled. So this is pretty intuitively obvious sort of relationship, which we had seen for the discrete case. It can be proven rigorously by using the definition of expected value. What about the variance? Variance of y. Variance of y is variance of ax plus b. Now, let me first ask you a question. कि ये variance of ax plus b, well, maybe before asking the question, I should ask for the answers in the chat window. What is the variance of ax plus b? What is the variance of ax plus b? Any takers? ये हमने देखी है डिस्क्रीट के केस में, एग्जैक्टली सेम रिलेशनशिप है, एग्जैक्टली वही है. Nobody is here. This would be a square variance of x. A square variance of x. A square variance of x. So basically क्लास के स्कोर के अंदर मैं अगर एक कांस्टेंट ऐड करता जाऊं, हर स्कोर के अंदर कांस्टेंट ऐड करता जाऊं, हर स्कोर में कांस्टेंट ऐड कर दूं, तो it doesn't change the standard deviation or the variance. Standard deviation is just the square root of the variance. हर स्टूडेंट को अगर 2 मार्क्स एक्स्ट्रा दे दें, 2 मार्क्स एक्स्ट्रा दे दें, does change the mean value, but does not change the standard deviation. Does not change the standard deviation. Okay. So if I multiply every student's score by 3, हर स्टूडेंट के स्कोर को 3 से मल्टीप्लाई कर दूं तो स्टैंडर्ड डेविएशन गेट्स मल्टीप्लाइड बाय 3. The standard deviation gets multiplied by 3. Okay, so standard deviation gets multiplied by 3, so the variance will get multiplied by 3 का square, which is 9. So a square से ये multiply हो जाएगी. This is the relationship which we have seen in the discrete case as well, and the same is coming up in the continuous case too. Okay, so now I'm going to give you examples of random variables. So we saw this last time as well, a uniform random variable, जो अभी हमने define भी कर दिया, uniform random variable. Okay, so the uniform random variable is uniformly distributed, which means the PDF is constant. PDF is constant over the range 0 to 1. Okay, so this is a uniform over the interval 0 and 1. Over the interval 0 and 1. So इसको अक्सर ऐसे लिखते हैं यूनिफॉर्म 0,1. Uniform 0,1. So this is your density function PDF. This is small x here, and we say that x, oops, x is uniform. इसको ऐसे लिख देते हैं between 0 and 1. You can also have uniform between some other numbers. Okay. Now, what is the probability? What is the probability? X takes a value less than equal to x, which is our fx of x. This is, we have seen previous example, this is simply equal to x. Why is that? This is the probability x takes a value less than equal to this number. इसको small x के बजाय a कर देते हैं. So a here, this is simply this. Okay. So the CDF is simply a linear function. Is a linear function here. So CDF ये हमने पहले भी देखा, ये इस तरह का होगा. So this is CDF. This is CDF. What is the expected value of x? मालूम कर लें. X into 1, this which is the height here, 0 to 1 dx, which turns out to be 1 over 2. What about variance of x? Variance of x would be equal to expected value of x square minus expected value of x whole square. Okay, we already know this guy on the right. ये वाला क्या चीज है? ये वाला क्या चीज है? Expected value of x square. This is simply the expected value of a function of a random variable. Expected value of a function of the random variable, which is x square, into the PDF, which is 1 dx, again integrated from 0 to 1. So this would be 1 over 3. This would be 1 over 3. So the variance of x would be equal to 1 over 3 minus 1 over 2 whole square. So 1 over 3 minus 1 over 4, which is equal to 1 over 12. 1 over 12. This is the variance of a uniform random variable, which is between 0 and 1. Okay. What if x is uniform from A to B? Okay. By the way, this A is different from this A. So what if x is uniform between A and B? If x is uniform between A and B, then the probability density function will look like this. Will look like this. Between A and B, this guy is uniform. Okay, and 0 otherwise. And 0 otherwise. You have small x here, x here. What is the height? What is the height of the PDF here? Answers in the chat window. Height of the PDF, answers in the chat window. ये वैल्यू क्या है जहां पे क्वेश्चन मार्क लगा है? Yeah, this value is 1 over b minus a, and the reason it is 1 over b minus a is कि ये area under the curve जो है, this is probability density function, इसके नीचे area आपका 1 होना चाहिए. तो how can you get the area of 1 is because this area has to be 1. So it's only when the height of the uniform function is 1 over b minus a. You can verify that the expected value of x intuitively हमें क्या लगती है, और वही आंसर आएगा. Intuitively ऐसे लगती है कि इसके यहाँ दरम्यान में कहीं पे expected value. बिल्कुल उसी तरह जैसे 0 और 1 पे expected value was in the middle, यहाँ पे भी expected value is between a and b is a plus b over 2. इसकी वर्किंग जो है वो नोट्स में दी हुई है and it's very easy to show. So but please take a look at that. What about variance of x? What about variance of x? Variance of x हमारे पास आती है. Again you can solve it by using the same formula. ये जो हमने यहाँ पे यूज किया है इसको यूज कर सकते हैं. It will be b minus a whole square over 12. Whole square over 12. And you can readily verify कि when b is 1, a is 0, तो आपके पास ये uniform 0 1 है. When b is 1, a is 0, you will get the answer 1 over 12 जो हमने यहाँ पे निकाला हुआ है पहले. जो हमने पहले ही निकाला हुआ. Okay? All right. Now, uniform random variable is interesting because you can generate other random variables from the uniform random variable. Okay. How is that possible? Okay. I'm going to just quickly touch upon that. Generation of a random variable from uniform. So, normally क्या होता है? Normally आप computers के अंदर MATLAB में या many calculators, the random function, the random variable that you generate is typically uniform. So you generate a uniform random variable. It's very hard to generate a random variable, by the way. A true random variable generate karna is very difficult. But normally what you generate, typically what you generate is a uniform random variable. अगर मुझे कोई और तरह का random variable चाहिए हो जिसकी probability density function कुछ और हो, तो फिर हम वो कैसे करते हैं? वो जनरेट करने के लिए we define y as a function of a uniform random variable. किसी function में से उसको गुजार देते हैं. So e to the power x for example is one function. कोई और भी functions हो सकते हैं. 3x plus 5 ये भी हो सकता है. 7x square minus 3x plus 2 एक और function हो सकता है. So you generate a uniform random variable and then you can get another random variable from that uniform random variable. Okay. Now, let me ask you this question. Okay. Suppose we want to generate a random variable, want to generate x with CDF fx dot. हम इस CDF के साथ जनरेट करना चाहते हैं. ठीक है. So assume इसको जनरेट करने के लिए assume करते हैं कि y is equal to capital Fx of x. ये एक ऐसा random variable है. Y is a random variable, is a function of x. लेकिन ये एक ऐसा फंक्शन है कि ये जो मेरा CDF वाला फंक्शन था मैंने उसी को ऐसे फंक्शन के तौर पे इस्तेमाल कर लिया. ठीक है. Then probability y is less than equal to small y would be equal to the probability that fx of x is less than equal to y, which is equal to the probability that x is less than equal to fx inverse of y. ठीक है. कुछ भी नहीं किया, अंदर वाली एक्सप्रेशन के अंदर दोनों साइडों पे fx इनवर्स ले लिया. इनवर्स फंक्शन दिया है तो इसका इनवर्स फंक्शन लेंगे तो बस x आ जाएगा, इसका इनवर्स फंक्शन लेंगे तो fx inverse of y आ जाएगा. So this is equal to, well, I recognize something here. Probability x less than equal to something is the CDF of x. The CDF of x evaluated at this value, which is fx inverse of y. So ये आपके पास simply y आ जाएगा. But when is probability y less than equal to y is equal to y? ये भी हमने ऊपर recognize किया कि probability x less than equal to a is equal to a only in the case of uniform 0 1. So यहाँ पर probability y is less than equal to y, which is the CDF, and CDF uniquely tells you about the random variables. Remember हमने कहा था कि CDF आपको हर चीज बता देता है random variable के बारे में. ये नहीं हो सकता कि दो different random variables का एक ही CDF. ये भी नहीं हो सकता एक random variable के एक से ज्यादा CDF. So one CDF, one random variable. Okay. So this CDF, probability y less than equal to y is equal to y. This guy is uniform 0 1. क्यों? ये 0 से छोटा भी नहीं हो सकता because CDF है, और ये 1 से बड़ा भी नहीं हो सकता because CDF है. So this is the range is automatically set between 0 and 1. So this is the CDF of uniform random variable. Okay. So अब हमने कैसे एक रैंडम वेरिएबल x विद CDF fx डॉट जनरेट करना है. ऐसे जनरेट करना है कि फर्स्ट जनरेट प्रोसीजर क्या होगा. प्रोसीजर इज generate a uniform 0 1 which is y, okay, and then use x is equal to fx inverse of y to get the desired x. Desired x means a random variable x with that density function, with that CDF that you wanted. There is an example जो notes के अंदर दी गई है, kindly उसको जरूर देख लीजिएगा. So the other random variable that we talked about last time was exponential random variable. Exponential random variable, it's a good model for waiting for something to happen. Exponential random variable. The time until I receive a data packet on a computer network, until I receive the next packet, that can be modeled as an exponential random variable. The lifetime of a light bulb, when I turn it on, कितनी देर तक ये चलता जाएगा, that could be an exponential random variable. The time until a meteor strikes the earth, that could be modeled as an exponential random variable. Okay. The time until my turn comes up in PDC line, that can be modeled as an exponential random variable. So exponential random variable is the time until something happens. That is an exponential random variable. Okay. Now you can see a close relationship with geometric. Geometric क्या होता था? वो discrete के केस में होता था कि आप dice roll किए जा रहे हैं जब तक 6 नहीं आ जाता, and 6 is a success. So you keep on trying until you see the first success. That was your geometric random variable. In the case of geometric random variables, you were waiting for the success. You were waiting for a particular event to happen. कि dice roll करेंगे और 6 आ जाएगा. That's a success, and the number of rolls that you need to perform until you see the success is a geometric random variable. Discrete है, कितने टॉस करने पड़ेंगे आपको, कितनी दफा डाइस रोल करना पड़ेगा. Discrete है, geometric उसको डिफाइन करेगा. ठीक है. Now if I tell you कि एक यूनिट टाइम के बाद मैं डाइस रोल कर देता हूं, बताएं कि कितने टाइम के बाद आपके पास 6 आ जाएगा. That would be an exponential random variable. So see a close relationship between exponential and geometric. So the probability density function of an exponential random variable x is equal to lambda e to the minus lambda x, where lambda is a constant. We write x is an exponential random variable with parameter lambda. बिल्कुल उसी तरह जैसे बर्नूली में p उसका पैरामीटर होता था, बाइनोमियल में n और p पैरामीटर होते थे, पोसॉन में लैम्डा उसका पैरामीटर होता था. बिल्कुल उसी तरह एक्सपोनेंशियल के अंदर लैम्डा इज अ पैरामीटर, सिंगल पैरामीटर. ओके. एंड लास्ट टाइम आसिम की क्लास में हमने ये भी देखा था कि दिस इज क्लोजली टाइड विद द पोसॉन अराइवल्स. इफ द थिंग्स आर अराइविंग अकॉर्डिंग टू पोसॉन डिस्ट्रीब्यूशन, कि आपके पास पैकेट्स अराइव हो रहे हैं, डेटा पैकेट्स अराइव हो रहे हैं कंप्यूटर नेटवर्क के ऊपर, तार के ऊपर आपके पास पैकेट्स आ रहे हैं. सो इफ दे आर अराइविंग अकॉर्डिंग टू द पोसॉन डिस्ट्रीब्यूशन, एक आ गया, फिर दूसरा आ गया, तीसरा, प्रोबेबिलिटी that you have 7 packets is given by the Poisson distribution. Probability you have 3 packets is also given by the Poisson distribution. So उनके पास अगर Poisson arrivals हैं, so the arrival time between any 2 packets, एक पैकेट आने के बाद जो दूसरा पैकेट आएगा, टाइम कितना लगेगा, that is given by exponential. ये last time आसिम ने शो भी किया था mathematically, and an explanation of that in a more generalized form is also given in the notes. So please take a look at that as well. So this is your PDF. This is your PDF probability density function. What about the cumulative density function, cumulative distribution function? F of x is equal to minus infinity to x lambda e to the minus lambda t dt. And this will turn out to be 1 minus e to the minus lambda x. Shape कैसी है? ये कैसे लगती है? Now, when we said कि exponential जो है वो waiting time के लिए इस्तेमाल होता है, waiting time कभी 0 से छोटा नहीं होगा. PDC की लाइन में आपकी बारी जो आनी है, it will never be a negative time. So typically, this is how the distribution might look like. ये ऐसे लगेगी. And कितनी quickly fall करता है depends on lambda. Lambda अगर बहुत बड़ा होगा तो ये quickly से fall कर जाएगा. Lambda बहुत छोटा होगा तो बहुत slowly fall करेगा. ठीक है? This is your probability density function. This is how it looks like. What about the CDF? The CDF is run from this. CDF will look something like this. ये 1 पे चला जाएगा, 1 से ऊपर नहीं जा सकता. CDF 1 से ऊपर नहीं जा सकता. ठीक है, और ये 0 से स्टार्ट होगा. This is capital FX of X. This kind. What about the expected value and the variance? The expected value, again, you can find out x into lambda e to the minus lambda x dx. इसको integrate करें. कहां से कहां तक? माइनस इंफिनिटी से प्लस इंफिनिटी तक. बट यू नो दैट माइनस इंफिनिटी से 0 तक तो ये चीज ऐसी 0 हो जाती है डेंसिटी फंक्शन आपकी. सो दिस वुड बी 0 to infinity, and this will turn out to be equal to, इसको इंटीग्रेट करेंगे बाय पार्ट्स, 1 over lambda. Similarly, expected value of x square, this will turn out to be 2 over lambda square. And what about the variance of x? Variance of x would be equal to 2 over lambda square minus 1 over lambda whole square, which is equal to 1 over lambda square. 1 over lambda square. There is a working example, very simple example of an exponential random variable जिसमें lambda दिया हुआ है आपको, आपसे expected value पूछी है, एक probability पूछी है. So just take a look at that. There is a very interesting property about the exponential random variable. By the way, ये जो waiting time है, इसकी modeling हम exponential से कर सकते हैं, लेकिन इस जरूरी नहीं है exponential से ही, किसी और distribution से भी model हो सकती है. किसी और डिस्ट्रीब्यूशन से भी मॉडलिंग हो सकती है. ओके, so human life is probably not the right fit for distribution according to the exponential distribution. एक्सपोनेंशियल के साथ हम उसको शायद मॉडल नहीं करेंगे, क्योंकि एक्सपोनेंशियल तो ये देखें आपके पास ये इनफाइनाइट तक जा रहा है. ह्यूमन लाइफ जो है वो इनफाइनाइट तक नहीं जाएगी. 70, 80, 100, 120 बस खत्म. उसके बाद so this guy goes up to infinity. You will not want to model the human life according to the exponential distribution unless के इसमें कोई आप उसको truncate करें, कुछ ना कुछ करें. So a very interesting property about exponential random variable is exponential and memoryless property. इसका क्या मतलब है? इसका मतलब ये है कि अगर मैं आपको ये बता दूं कि ये लाइट बल्ब जो है ये 2 घंटे जल गया, अब मुझे उसकी लाइफ टाइम बताएं, तो इट वुड बी द सेम आंसर कि अगर मैंने आपको ये ना बताया होता कि ये 2 घंटे जल गया. सो इन अदर वर्ड्स, द if x is exponential random variable with some parameter lambda कुछ भी हो सकता है, then the probability x is greater than s plus t, and s and t are constants. Given that x is greater than t. अब मैंने आपको बता दिया है कि x is greater than t. This is given to you. I'm asking you the question, what is the probability x is greater than s plus t, which means an additional s units of time spend करेंगे. This can be ये conditional probability आपके पास. So conditional probability का formula लिखेंगे, x is greater than s plus t and x is greater than t divided by probability x is greater than t. And इसकी values अगर आप ऊपर put करें, x is greater than t and x is greater than s plus t, ये इसका subset. This event is a subset. So x is greater than s plus t divided by probability x is greater than t. इसको, this is 1 minus CDF. क्योंकि CDF होता है x is less than equal to. So x greater than होगा तो ये 1 minus CDF होगा. So इसको solve करें and you will be getting e to the minus s plus t lambda. So CDF आपके पास था 1 minus e to the minus lambda x. Okay. So उसको 1 से minus करेंगे तो e to the minus lambda. This would be e to the minus t lambda. So this turns out to be e to the minus s lambda, which is the same as the probability x is greater than s. So relate these two guys. ये आपको memory less बताते हैं, memory less. Okay, given that you have spent t units of time, what is the probability that you will have an additional s units of time until some interesting event happens? Is the same as that you have x greater than s. You start from scratch and you have additional s units of time. देखिए ज्योमेट्रिक में भी ऐसे होता था, ज्योमेट्रिक में भी ऐसे हो सकता था. So ज्योमेट्रिक के अंदर भी when you are rolling a dice until you see 6, ठीक है, अगर आपको 3 टॉसेस करने के बाद, मैंने आपको बता दिया अभी 6 नहीं आया, पहले तीन जो आपने रोल्स किए डाइस के उसमें 6 नहीं आया, तो फिर what is the remaining time? वो टाइम कम नहीं होगा, क्योंकि आप इंडिपेंडेंट ट्रायल्स कर रहे हैं. ऐसा नहीं होगा कि आपने 3 टॉसेस पहले कर लिए हैं, 6 नहीं आया तो अब आपको जल्दी 6 आ जाएगा. नहीं. Given that information, you will still have to probabilistically wait the same amount of time, okay, on average. Okay.
Excuse me, sir.
Yes.
सर ये एक्सपोनेंशियल रैंडम वेरिएबल को मॉडल करने का मतलब ये जो आपने फंक्शन लिखा है जो इसको मॉडल कर रहा है, ये फंक्शन लाइक आता कहाँ से है? हम पोसॉन वेरिएबल से ही ये आगे ड्राइव करते हैं सारे?
पोसॉन से ये डिराइव कर सकते हैं, लेकिन ये मॉडल, ये फंक्शन जो मैंने लिखा है, फंक्शन एक्सपोनेंशियल को मॉडल नहीं कर रहा. ये दिस फंक्शन इज एक्सपोनेंशियल रैंडम वेरिएबल, ये उसकी डिस्ट्रीब्यूशन है. This distribution is for an exponential random variable. I can model a physical process by using the exponential random variable. ठीक है, फिजिकल प्रोसेस को, जैसे बैंक के अंदर वेटिंग टाइम है या पीडीसी की लाइन में वेटिंग टाइम है, उसको मैं एक्सपोनेंशियल से मॉडल कर सकता हूं, अप्रोक्सीमेट कर सकता हूं. लेकिन एक्सपोनेंशियल की ये जो डेफिनेशन है, दिस इज ए फिक्स्ड डेफिनेशन, दिस इज ए एक्यूरेट परफेक्ट डेफिनेशन.
सही है. तो सर आपने बताया कि ह्यूमन लाइफ नहीं इससे मॉडल हो सकती, तो इसका मतलब ये वाली इंट्यूशन लाइक विद एक्सपीरियंस बिल्ड होती है या आई मीन इसका कोई रूल्स है?
इसका रूल ये है कि ये देखें, एक्सपोनेंशियल रैंडम वेरिएबल में रैंडम वेरिएबल कैन टेक अ वैल्यू इंफिनिटी. ह्यूमन लाइफ विल नेवर टेक अ वैल्यू इंफिनिटी.
यप,
ठीक है. ओके, नाउ देयर इज एन एक्सटेंशन. There is an extension of an exponential random variable which is called the gamma random variable. ये भी हमने last time पढ़ा था. Gamma random variable. So this is a simple extension of exponential random variable. देखिए, हमने क्या कहा था कि exponential random variable is the waiting time until something interesting happens. Gamma random variable is the waiting time until an interesting event happens a few number of times. आपको 6 डेटा पैकेट मिलते हैं ऑन अ कंप्यूटर नेटवर्क, या आपको 6 लोगों की बारी जो है वो पीडीसी की लाइन में खत्म हो जाती है, समथिंग लाइक दैट. सो यू कैन सी कि जहां पे अगर मैं टाइम स्टार्ट कर दूं, ये मैं टाइम स्टार्ट कर दूं और ये टाइम चलता जा रहा है. सो यू स्टार्ट फ्रॉम स्क्रैच, t इज इक्वल टू 0, यहां पे चलते गए, यहां कुछ इंटरेस्टिंग चीज हैपन करती है, ठीक है, एंड देन यहां पे फिर कुछ इंटरेस्टिंग चीज हैपन होती है, यहाँ पे फिर कुछ इंटरेस्टिंग चीज हैपन होती है, एंड सो ऑन एंड सो फोर्थ. यहाँ पे कुछ इंटरेस्टिंग चीज हैपन होती है, फिर यहाँ पे कुछ इंटरेस्टिंग चीज होती है. सो in between these guys, ये interesting चीज happening, this interesting चीज happening, this interesting चीज happening, each of these can be modeled as an exponential random variable. क्यों? क्योंकि मैं एक interesting event का वेट कर रहा था, वो हुआ, तो exponential random variable जो है उसकी वैल्यू आ गई मेरे पास, ठीक है. What is a gamma random variable? Gamma random variable is just the sum of these, के 3 इवेंट्स के लिए, 3 पैकेट्स रिसीव करने के लिए, या 3 लोगों को बैंक की क्यू में से फारिग करने के लिए आपको कितना टाइम चाहिए होगा, that would be given by a gamma random variable. A gamma random variable. An interesting event happened multiple times. So the probability density function of the gamma random variable, ये derive भी की गई है by the way, class notes के अंदर है. So the probability density function of a gamma random variable is simply lambda e to the minus lambda x. Remember ये हमारे पास exponential थी, यहीं से start करेंगे और यहीं से start करने के बाद इसको lambda x power alpha minus 1 divided by this gamma function of alpha. And gamma function is really, gamma function of alpha is alpha minus 1 factorial. Gamma alpha is equal to alpha minus 1 factorial. Okay. For the case when alpha is an integer. For the case when alpha is an integer. For the case when alpha is not an integer, there is a definition of gamma function जो class notes में दी गई है, वहां से देखना. So you can see कि this distribution here, इसमें ये वाला जो portion है ये तो exponential ही है और ये कुछ additional चीज आ गई. So we say that x as a gamma distribution with parameter lambda, lambda जो है ना वो आपको ये बताता है, exponential के केस में भी लैम्डा ये बताता है कि आपको ऑन एवरेज कितना वेट करना पड़ेगा. देखिए एक्सपोनेंशियल का जो मीन था वो आपके पास 1 over लैम्डा था. इफ लैम्डा इज हाई तो आपको बहुत थोड़ा सा वेट करना पड़ेगा, ऑन एवरेज बहुत थोड़ा वेट करना पड़ेगा. वो भी हमने रिमेंबर हमने कहा था कि ये डिस्ट्रीब्यूशन फॉल कर जाएगी जल्दी. इफ लैम्डा इज हाई देन डिस्ट्रीब्यूशन विल फॉल क्विकली. हाई लैम्डा पे दिस विल गो लाइक दिस एंड स्लो लैम्डा पे दिस विल गो लाइक दिस. ओके, सो स्मॉल लैम्डा and this guy is large lambda. So lambda अगर large होगा तो expected value small हो जाएगी. Now this lambda tells you that the rate of decay of the exponential random variable. Now for the gamma random variable, ये lambda तो आपके पास है कि until one event happens, but we are not waiting for one event to happen. We are waiting for multiple events to happen. How many events to happen? Alpha events to happen. By the way, ये जो हमने definition आपको बताई है, इसमें ऐसा लगता है कि one event happen करता है, फिर 2, फिर 3, तो alpha जो है वो integer होगा. Well, alpha integer हो सकता है, but it is not required for the gamma random variable to have alpha to be an integer. जब अल्फा इंटीजर है तो ये बड़ा आसान है सोचना कि 5 कस्टमर्स को फारिग करना है क्यू के अंदर से, कितना टाइम लगेगा उसके लिए, ये हमारा रैंडम वेरिएबल, उससे मॉडल करते हैं. व्हेन अल्फा इज नॉट एन इंटीजर, व्हेन अल्फा इज 4.2, तो इट्स हार्ड टू थिंक कि ये 4.2 कस्टमर्स को आपने फारिग करना है, वो कैसे फारिग करेंगे. सो gamma रैंडम वेरिएबल की जो डेफिनेशन है, इट इज मच मोर जेनेरिक. not just for integer values of alpha. It has two parameters, alpha and lambda. Alpha and lambda. Okay. When lambda is large, then you will have to wait for a shorter period of time for events to happen. When lambda is small, then things will happen quickly. Excuse me. When lambda is small, then मुझे लगता है ये मैंने उल्टा लिख दिया है यहाँ पे. ऐसे लिखा. ठीक है. This is all right. When lambda is small, you will have to wait for a long period of time. Now, I'm going to just switch to normal random variable. One of the most useful, most interesting random variable. Many natural phenomena, they can be modeled by a normal random variable. Many natural phenomena can be modeled by a normal random variable. The probability, this is a symmetric probability distribution and looks like this. ये जो bell curve होता है हमारा, ये इसको हम standard bell curve कहते हैं, इस तरह. So it has a center point which is the mean value mu से denote करते हैं and has a fatness. ये जो आपके पास bell बनी हुई है, ये thin भी हो सकती है, ये fat भी हो सकती है. Whether this is thin or fat, this is indicated by the standard deviation. The standard deviation. अगर standard deviation ज़्यादा होगी, तो the bell will be fatter. If the standard deviation is small, then the bell will be thinner. The bell will be thinner. What is the mathematical expression for the density function here? The mathematical expression is 1 over square root 2 pi sigma. Sigma is outside the square root. E to the minus x minus mu whole square over 2 sigma square. And minus infinity x less than plus infinity. So this distribution goes from minus infinity to plus infinity. This naturally occurs in many situations. लोगों की height हो गई, size of snowflakes हो गया, and many examples given in the notes. Measurement errors जो है वो अक्सर normal distribution से होती है. Error आपकी positive होगी या negative होगी. आपने कोई चीज measure करनी है, you cannot accurately measure that thing. You can only measure this up to the precision of the instrument that you have. अगर आप उसको measure कर रही हैं, so there will be some measurement error. That error is modeled by the normal distribution. Now, in the notes we have shown that this is the probability density function, which means that this guy integrates to 1, and it is never negative. It is also symmetric. Symmetric क्यों है? क्योंकि ये x minus mu square है. X को इसको mu के around ये symmetric होगा. Mu के around symmetric होगा. So now I'm going to talk about the expected value. Expected value of x is mu, and the variance of x is this sigma square guy. ये sigma जो यहाँ पे आ रहा है या जो sigma यहाँ पे आ रहा है, variance is sigma square. ये भी show कर सकते हैं. And again, it's shown in the notes for the completion of discussion. We will not show it here. You can छोटी classes में देखा होगा पहले इसको. Now linear transformation and standard normal. Linear transformation and standard normal. Yeah. What does that mean? Linear transformation का क्या मतलब है? Linear transformation तो ये हमने पहले देखी. Ax plus b. This is a linear transformation. Y is a random variable. X is also a random variable. A and b are constants. So we say that y and x are linear functions. So हमने last time देखा expected value of x or y are related by this formula, variance of y is equal to a square variance of x. ये तो हमने देख लिया. For any random variable, discrete के केस में भी था, continuous के केस में भी था. Now, can we say something about the density function of y? So claim is if x is normal with mean mu and variance sigma square, this is the notation, with mean mu and variance sigma square, then y will also be normal. ये जो दो एक्सप्रेशंस हैं ये हमें ये नहीं बता रही हैं कि y की डिस्ट्रीब्यूशन क्या है, वो मुझे ये जरूर बता रही हैं कि y का मीन क्या है और y की वेरिएंस क्या है. ये जरूर बता रही हैं कि अगर x का मीन और वेरिएंस पता हो तो y का मीन और वेरिएंस निकाल सकते हैं. लेकिन इन इक्वेशंस से कहीं ये पता नहीं चलता कि if x is normal, then what is the PDF of y? Will y be normal or not? The answer is कि linear transformation of a normal is also a normal. So if x is normal, then y will also be normal. और उसका मीन क्या हो जाएगा? मीन और वेरिएंस हम यहाँ से कैलकुलेट कर सकते हैं. This would be a times mu plus b. This would be the mean, and the variance would be a square times the variance of x, which is a square times sigma square. And the proof that y is normal is also given in the notes. ये proof भी कर सकते हैं. Now, I can choose a and b and a such that this guy becomes 1 and this guy becomes 0. ऐसे choose कर सकते हैं हम, a और b के ऐसे values choose कर सकते हैं, right? This is entirely possible. Now, if I ask you a probability question about if x is normal with mean mu and variance sigma square, if I ask you the probability that x takes a value between 3 and 3.5, what is this probability? Easy है. ये take a look at this. So यहाँ पे 3 और 3.5 को identify करें. So maybe 3 is here, 3.5 is here. 3 is here, 3.5 is here. So this area under the curve, ये हम निकाल लें. This area under the curve कैसे निकलेगा? ये जो density function है, इसको integrate करते हैं 3 से 3.5 तक. ठीक है. Well, easier said than done. It's not easy to integrate this guy. In fact, you cannot integrate this guy just like that. इसके लिए हमारे पास इसके इंटीग्रल के टेबल्स मिलते हैं. But if I want to answer this question, that probability x takes a value between 3 and 3.5, क्या मुझे उसका टेबल मिलेगा? Well, I cannot provide tables for every possible value of mu and every possible value of sigma. Every possible value of mu or every possible value of sigma. मैं कर नहीं सकता. ठीक है. So what they have done is, उन्होंने कहा कि हम standardization करते हैं. ठीक है. Standardize the normal to normal 0, 1 में standardize कर देते हैं. Standardize करने के बाद ये normal 0, 1 के आप टेबल प्रोवाइड कर दें. सिर्फ उसके टेबल प्रोवाइड करने, and then using those table you can answer the question about any normal with any mean and any variance. Okay, so tables, probability tables available for normal 0, 1 can answer questions, probability questions, can answer probability questions about any normal with mean mu and variance sigma square by using a transformation method here. Okay. And what is that transformation method? That transformation is pretty simple. Let's say you have x, which is normal with mean mu and variance sigma square. Let's try to find a transformation between x and z, which is also normal, mean 0 and variance 1. मुझे पता है इसके टेबल्स मिलते हैं, इसके टेबल्स नहीं मिलते। क्यों नहीं मिलते? क्योंकि म्यू और सिग्मा स्क्वायर भी इनफाइनाइट वैल्यूज पॉसिबल हो सकते हैं, उतने टेबल थोड़ी हम बना सकते हैं। बस एक टेबल हमने बना दिया है और वही टेबल हमारे सब काम करेगा। सो नाउ आई कैन राइट कि x is sigma z plus mu. Everyone agrees with this? Everyone agrees with this कि expected value of x जो हो जाएगी वो expected value of z times sigma which is 0 plus mu हो जाएगी which is this, and the variance of x would be equal to sigma square variance of z. ये हमने कुछ भी नहीं किया इसके अंदर, बिल्कुल ये वाली दो एक्सप्रेशंस इस्तेमाल की, ये वाली दो एक्सप्रेशंस इस्तेमाल की। सो इसको रीअरेंज कर दें अगर, तो इसको हम कर सकते हैं x माइनस म्यू ओवर सिग्मा। सो इसका क्या मतलब है? इसका मतलब ये है कि मुझे अगर x के बारे में कोई भी प्रोबेबिलिटी क्वेश्चन आंसर करना है तो मैं x में से मीन माइनस करूंगा, स्टैंडर्ड डेविएशन से डिवाइड करूंगा, आई विल गेट अ रैंडम वेरिएबल व्हिच इज नॉर्मल 0 1। आई विल गेट अ रैंडम वेरिएबल व्हिच इज नॉर्मल 0 1 जिसके लिए टेबल्स अवेलेबल है, जिसके लिए हमारे पास टेबल्स अवेलेबल है। ठीक है? So quick example of this. Let's say you are given x as normal 2 and 9. Mean is 2 and the variance is 9. Mean is 2 and the variance is 9. Very simple. What is the probability? X is less than 3.5. Cannot answer this question. I don't have a table for that. However, I can write this as probability x less than 3.5 is the same as the probability x minus 2 over sigma is 3 is less than 3.5 minus 2 over 3. कुछ भी नहीं किया, ये अंदर ये भी जो x में से 2 माइनस करके 3 से डिवाइड किया, 3.5 के साथ भी वही काम किया, 3.5 में से 2 माइनस करके 3 से डिवाइड किया। So same expression both sides. ठीक है? However, if you look at this guy here, जो x में से उसका मीन माइनस हुआ है और स्टैंडर्ड डेविएशन से डिवाइड किया हुआ है, so this becomes a standard normal z is less than 3.5 minus 2 is 1.5 over 3, which is 0.5. Now z is normal 0 1. Z is normal 0 1. If z is normal 0 1, I can simply look at the table. And answer this question. So probability that x is less than 3.5 is the same as probability z is less than 0.5. I have no table for this. I have a table for this. And this is called the CD. This is the CDF of z. इसके टेबल मिल जाते हैं. And this is sometimes written as phi of 0.5, which is the same as fz of 0.5, the CDF of z. ये notation है जो phi अक्सर लिख देते हैं. And from the table, you can see that this will turn out to be 0.6915. So I may have a table here. Let's see. The table looks like this. So ये देखें, ये 0.5 है और 0.5 पे ये 0.6915. यही हमने आंसर लिखा था. ठीक है. 0.52 होता तो ये आंसर होता. 0.5 और ये 2 तो ये वाला आंसर होता. And you can see that these answers are given only for positive values of c. Negative values के लिए भी आंसर होंगे, वो निकाल सकते हैं इसमें से. Okay. So reading the CDF of z from the table, this is something that we will do a couple of examples of this next time. I will also cover the binomial approximation. एक बाइनोमियल रैंडम वेरिएबल को आप नॉर्मल से अप्रोक्सीमेट कर सकते हैं. नाउ यू माइट से कि बाइनोमियल रैंडम वेरिएबल तो डिस्क्रीट होता है और नॉर्मल रैंडम वेरिएबल कंटिन्यूअस होता है. इन दोनों की अप्रोक्सीमेशन कैसे आएगी आपके पास? सो वी विल सी नेक्स्ट टाइम we will cover the central limit theorem, which is one of the two major results in probability theory, the other being the law of large numbers. There are two major results in probability theory, two remarkable results in probability theory. One is the law of large numbers, the other is the central limit theorem. So we'll talk about both of those next time. If there are any questions, abhi agar koi hai, to please go ahead and ask. And next time we will finish this this business of single random variable and start with the multiple random variables in the next lecture. Quick questions? Quick questions? Okay, great. So I will stop the sharing and close the session here. We'll upload the video as soon as it is available. We already have the notes from the lecture today already available on the website. LMS पे available है. Additional notes for Friday's lecture जो भी होंगे वो फिर मैं उसमें add ही कर दूँगा. Okay, and I will send an email के updated handout जो है वो upload हो गया. Great, thank you very much.